Welcome back to KV Education Point. In this video, we will discuss about chemical kinetics. Firstly, we have to know about what is chemical kinetics. A chemical kinetics, it is a branch of chemistry that deals with the rate of chemical reaction, like on what factors rate of reaction depend. As we know that in a chemical reaction, there will be a breakage of bond and new bond will form. So in the breaking of bond, there will be heat ejected, and in the formation of product, there will be heat evolved. That's why different chemical reaction will proceed at different rate. Now, first topic is rate of reaction. What is the rate of reaction? Rate of reaction is simply change in concentration with respect to time. Change in concentration with respect to time. Suppose there is a reaction in which A gives product. If I am saying at the start of reaction, or we can say when T is equal to 0, there will be only reactant, no product. And when the time starts at T is equal to T, then there will be decomposition of reactant, and जितना reactant decompose होगा उतनी ही product की formation होगी. Suppose I am saying A minus X, then there will be production of X. ठीक है? So what I am saying, like with respect to time, the concentration of reactant decreases, and with respect to time, the concentration of product increases. So I am saying increase in the concentration of product upon time, and I am saying decrease in the concentration of reactant with respect to time. Now we will study about the unit of rate of reaction. As we know that the concentration unit is mole liter inverse, and divide में है time, तो ऊपर जाके time हो जाएगा second inverse, and time R inverse, minute inverse, up to so on. Also we can write as we know that 1 liter is equal to 1 decimeter cube. So we can change this unit into mole decimeter inverse cube second inverse, mole liter inverse minute inverse, mole liter inverse, that is R inverse. Hope so आपको इतना समझ आ गया होगा. After that, if I am saying there will be small change in the concentration dx of reactant or a product, and small change in time, like interval of time, that is dt, so I can write as rate of reaction is equal to dx by dt, but for reactant I can write as minus dx by dt, and for product I can write dx by dt. So negative sign depicts that there will be decrease in the concentration of reactant with respect to time. Okay? एक minute. If I'm saying I have the reaction A plus B gives L plus N, then how can I write as the expression for a rate of reaction is minus dA by dt is equal to minus dB by dt, because minus क्यों लगाया, क्योंकि मैं reactant के लिए लिख रही हूँ, and for product plus dL by dt plus dN by dt. Now if stoichiometric coefficients are present, then how can we write the expression for rate of reaction? Let's discuss that. Okay, I have a reaction this. Now, if I am saying that I have to write the rate of expression for this reaction, then A, B, L, M, these all are the stoichiometric coefficient. Then we will write as reciprocate the stoichiometric coefficient minus 1 by A, dA by dt, minus 1 by B, dB by dt, minus 1 by L, positive, because for product, dL by dt is equal to plus 1 by M, capital dM by dt. After that, hope so आपको इतना समझ आ गया होगा. After that we will study how many factors in which rate of reaction depends. Factors on which rate of reaction depends. First factor is concentration of reactant. Okay. As we know that at the start of reaction, हमने पहले ही study किया है, at the start of reaction concentration of reactant is high, but with the increase in time, the concentration of reactant decrease. We can also study this with the example of collision theory, like there are number of collisions जितने होंगे per unit time उतना ही reaction proceed करेगा faster. So I am saying that with the increase in concentration of reactant, rate of reaction decreases, which means it is inversely proportionate to the concentration of reactant. That means the graph will be concentration of reactant with respect to time decreases. ठीक है? Like I am saying, increase in concentration of reactant, there will be decrease in rate of reaction. Okay. The next factor is, the important factor is like nature of reactant. If I am saying I have a reaction in which H2 plus Cl2 react gives 2 HCl and H2 plus Br2 gives 2 HBr, and I am saying this reaction is fast and this reaction is slow, then what does that mean? But if we see, these both the reactions are identical, but I am writing this reaction is fast as this reaction is slow, which means the nature of reactant is different. That's why these reactions react with different rate of reaction. At the start of the chapter, I am saying that different chemical reaction proceed with a different rate of reaction. So simply we can easily understand by this simple example. And the third one is temperature. Factor is temperature of a reactant. I am saying with the increase in temperature of reactant, rate of reaction increases. Then what does it mean? If I am increasing the temperature of reactant, then according to collision theory, the kinetic energy of reactant molecule increases, due to which number of collisions per second increases. That's why I am saying with the increasing temperature of reactant molecule, rate of reaction increases. Now, by the collision theory, according to collision theory, I am saying there will be, if there will be number of collision increases, then rate of reaction increases. But I am saying according to collision theory, only effective collision will proceed the reaction. What does effective collision means? Effective collision means not all the collisions are effective, only few collisions are effective which will proceed the reaction, like there will be breaking of bond, formation of product. So if I want there will be effective collision, then the minimum amount of energy that is required to proceed the reaction, that is termed as threshold energy. जो molecules minimum amount of energy reactant molecules के पास होनी चाहिए, इतनी energy तो that is threshold energy. और जो हमें एनर्जी सप्लाई करनी पड़ेगी ताकि हमारे कोलिजन्स इफेक्टिव हो जाएं, that is termed as activation energy. Then how we can calculate the activation energy? By activation energy is represented by EA. EA is equal to threshold energy minus कुछ ना कुछ एनर्जी ऑलरेडी मॉलिक्यूल्स के पास होगी, एनर्जी ऑफ द मॉलिक्यूल्स, दैट इज ET माइनस ER, रिएक्टेंट मॉलिक्यूल्स के पास. सिंपली अब I can say, like suppose if I am saying there is a reaction in which A2 plus B2 gives 2AB, then reactant molecules जब react करेंगे, then there will be a formation of activated complex which has short lifespan. After that it will convert it into product. Okay, like A, B, then suppose this is an activated complex. After that it will convert it into product. Okay. The graph will be potential energy and the progress of energy. Potential energy is represented in y-axis and progress of reaction is represented by x-axis. Potential energy, progress of reaction, like this is for ER, energy of reactant, energy of product. And this A2 plus B2 2AB. This is a threshold energy, जितनी मिनिमम एनर्जी रिएक्टेंट मॉलिक्यूल्स के पास होनी चाहिए ताकि कोलिजन्स इफेक्टिव हो जाए. ठीक है, और जो हमें एनर्जी सप्लाई करनी पड़ेगी रिएक्टेंट मॉलिक्यूल्स को ताकि उनकी एनर्जी थ्रेशोल्ड एनर्जी की इक्वल हो जाए, दैट इज टर्म्ड एज एक्टिवेशन एनर्जी. सो दिस इज अ थ्रेशोल्ड एनर्जी आई एम राइटिंग. ओके, दिस इज अ एक्टिवेशन एनर्जी EA. ठीक है, after that the next point is that is presence of catalyst. Fourth point is presence of catalyst. As we all know that catalyst speed up the rate of reaction. Why it speed up the rate of reaction? Because just it decreases the activation energy of forward reaction and backward reaction to the same extent. ठीक है, जिसकी वजह से क्या होता है कि जो रेट ऑफ एक्टिवेशन एनर्जी कम होगा सेम एक्सटेंट पे रेट ऑफ फॉरवर्ड और बैकवर्ड, तो जिससे क्या होगा इक्विलिब्रियम अटेन हो जाएगा फास्टर. ठीक है, और हम इसको कैसे रिप्रेजेंट करते हैं, लाइक इन द एक्सेस ऑफ कैटलिस्ट activation energy is this, like EP, or in the presence of catalyst, like this, uncatalyzed reaction, and this is catalyzed reaction. We decrease in activation energy. Progress of reaction and potential energy and progress of reaction. So this is enough for today. Now in the next video we will continue this chapter. Thank you. If you like this video, then please like, share and subscribe. Thank you for watching.